Yeah, good to go.
Okay. First of all, thank you, Professor Praveen, for your invitation. I'm Dr. Hosna Hajati. I'm from Sari, north of Iran, behind Caspian Sea, and now I'm assistant professor at Agri Research Center of Tabriz, Iran. Today, I want to share our experience about the effect of Bacillus licheniformis and Bacillus subtilis on growth performance, intestinal microbiota, and cytokine gene expression in broiler chickens. The outline of this presentation includes introduction, research work, result and discussion, conclusion, recommendation, and finally acknowledgements. First of all, I would like to remind you the problems of deaths from drug-resistant infections worldwide. Sorry. It is estimated that drug-resistant infection will kill more people than cancer over 3 decades. By 2050, 10 million people will die every year, unfortunately, and that will cause $100 economic losses. $100 trillion economic losses. Sorry, I have problem. Okay. But what we can do as a poultry nutritionist to alleviate the problem, one solution is to searching for antibiotic alternatives such as probiotics in order to have sustainable agriculture. WHO and FAO in 2002 defined probiotics as live microorganisms which when administered in adequate amount, have a health benefit on the host. And our two main targets of using probiotics in poultry nutrition are improvement of production performance in the farm and control of the gastrointestinal pathogens. But which characteristics should be considered when choosing probiotics? They should be host adapted, non-pathogenic, tolerate processing and storage, resist to gastric acids and bile salts, readily bind to epithelium and mucus, persist viability in the gastrointestinal tract, produce inhibitory substances against other bacteria, modulate immune responses, and actively competes for intestinal receptor sites. But how probiotics help farmers to have higher production index? Different researchers claim that probiotics can stimulate immune system and maintain intestinal, maintain intestinal by competitive exclusion and produce organic acids and enzymes, decrease ammonia production, decrease aflatoxin, and improve feed intake and nutrient digestibility, so we can have higher production index in the farm. There are different kinds of microorganisms used as probiotics in animal nutrition, and as you know, there are different kinds of bacteria, fungi, and yeast. Some of them are listed here. In this research, we focused on bacillus-based probiotics because they have excellent characteristics. For example, they are spore-forming, withstand high temperature up to 135 degrees centigrade, high intrinsic growth rate, high cell density cultivation, resistant to enzymatic digestion, produce enzymes, antimicrobial compounds, vitamins, and carotenoids, survive in anoxic conditions, neutralize anti-nutritional factors, and compatible with organic acid, coccidiostatin, and antibiotic growth promoters, and also approved by EFSA for application in feed. So the objective of the present study was to determine the effects of two bacillus-based probiotic sources on broilers. Broilers' cross-sperm performance, nutrients digestibility, and fecal microbial count, and cytokine gene expression, I mean interleukin-6, interleukin-10, and gamma interferon. In this research, we used a total of 180-day-old male broiler chicks with the initial weight of 40 grams. The duration of the experiment was 44 days, and the feed form was mash. And we divided the growth phases into starter, grower, and finisher. And we had 3 experimental diets in each phase. Diet 1 was control diet, diet 2 was control diet plus Bacillus subtilis, and diet 3 was control diet plus Leishmaniasis, and with the CFU of 10 in power of 9 per gram of feed. So we had 3 treatments, 6 replicates, and 10 birds each replicate. In this slide, you can see the ingredient and nutrient composition of Basil diets. As you can see, the diets were based on corn and soybean meal. Our considered traits were gross performance, body weight gain and feed intake measured on weekly basis, and the FCR was calculated accordingly. And also production efficiency factor was calculated according to the formula by Marco et al. 2013. And also we assessed the fecal microbial count on day 44. A total of 20 samples in each treatment were used for evaluating microbial count according to related references. And we assessed total aerobic bacteria, lactobacillus, yeast and mold, Enterobacteriaceae, and coliforms and Clostridium perfringens. Also, we assess the total tract and ileal nutrient digestibility. And in order to do that, we use a total of 60 broilers with similar average body weight, and we use metabolic cages for this trial. And acid insoluble ash in the concentration of 1% were used as a marker. And apparent nutrient digestibility coefficient of crude protein, calcium, and phosphorus, and AME were calculated by the following formula that's related to Stefanolo et al. 2016. Sorry. And also we assess the cytokine gene expression that I mentioned before, interleukin 6, interleukin 10, and interferon gamma. At day 42, blood samples of 12 birds in each treatment was collected, and the FDH was considered as internal control. Real-time quantitative polymerase chain reaction was performed in triplicate reaction using both forward and reverse primers. That you can see the primer sequences here in this slide. And the averaging expression was calculated by a delta CT formula according to Levac and Smithian 2001. Also, we assessed the probiotic bacteria penetration into the blood. The blood samples of 12 birds were collected at day 42, and according to the methods of Brutlet and et al. 2004, we do that, and we use a blood agar culture medium in this experiment. So the statistical design was CRD, completely randomized design, and we analyzed data by GLM procedure of SAS software. Okay, the results showed that Bacillus subtilis and Bacillus leishmaniformis didn't have any significant effect on feed intake of the birds. However, Bacillus leishmaniformis can improve body weight gain of the birds around 6.5%. Also, Bacillus leishmaniformis improve FCR or feed conversion ratio of the birds around 5%, and these are very important to us. Also, Bacillus leishmaniformis improved production efficiency factor about 12%, and this is very important for our farmers in the farm. However, Bacillus subtilis or Bacillus leishmaniformis didn't have any significant effect on the ileal microbiota or on the ceca microbiota, as you can see in these slides. Bacillus subtilis and Bacillus leishmaniformis improved protein total tract digestibility. And this improvement with Bacillus subtilis was around 12%, and with Bacillus leishniformis was around 9%. Also, apparent metabolizable energy of the diet improved by Bacillus subtilis around 6%, and it is improved by Bacillus leishniformis around 5%. But there were no significant differences in calcium or phosphorus digestibility among the birds. Also, there were no significant differences in the gene expression of cytokines, as I mentioned before, interleukin 6, 10, and gamma interferon. And probiotic preparations didn't have any significant effect on the relative weight of some digestive organs such as proventriculus, gizzard, or liver. Also, we assessed the pH of some digestive organs such as proventriculus, gizzard, ileum, and ceca, and the results showed that Bacillus subtilis and Bacillus leishniformis, I mean, both of them could decrease the pH of ileum of the birds. So it is maybe related to organic acid production by these, bacteria. And also, we assessed the livability of Bacillus subtilis and Bacillus leishniformis in our experimental diets after finishing the procedure, after, 45 days, we assessed the livability of these strains. And as you can see in this slide, Bacillus leishniformis had higher livability, and it is important to us in the farm situation. In conclusion, I would like to say adding 0.5 gram Bacillus leishniformis preparation to broilers' diet improved body weight gain and production efficiency factor of the birds. Adding Bacillus-based probiotics to broilers' diet improved AME and total tract protein digestibility of broiler chickens. And Bacillus species didn't penetrate into the bird circulation system. And so there is no likelihood of causing septicemia in consumers, which is very important for us. Regarding to our results, we recommend using 0.5 gram Bacillus leishniformis preparation with a count of 10 in power of 9 CFU per gram per kilogram of diet in broiler chickens during 1 to 44 days of age. And we recommend to continue the study to the effect of Bacillus strain on A and F, for example, phytate or NSP or so on, content in digesta. And we also recommend to study the interaction of Bacillus strain and other functional additives such as microalgae or insect bioactive peptides. I would like to thank my professor, Dr. Zaghari, and also Ms. Sarani. And thank you so much for your attention. If there is any question, please don't hesitate to contact me. My email is h.hajati@ro.ac.ir, and my WhatsApp number is 0098 91 11 56 66 84. Thank you so much again.